Good morning, everyone. Today we are going to be talking about memory for space and time for our memory class for this semester. So let's begin first by talking about this idea of how we look at memory for spatial representations. So the very first thing that we always want to try to understand related to the issues of space is that we can actually create mental maps that are mental representations of different locations, different areas that we may be interested in terms of our recollections, or even the way that we process certain information. We may want to create these mental maps for later usage. And a lot of these mental maps actually have very specific spatial characteristics related to them. So there may be issues related to distances between different objects. There may be issues related to amount of area that relates to that specific map, or there may be even specific landmarks that may help us identify specific information related to those specific areas. So when we look at this idea of mental maps, this is an idea that was originally proposed by Tolman that ultimately was used to try to explain how it was that rats actually learned their way around a specific maze, and trying to actually find their reward at the end of the maze a lot faster and faster with every single time that they would go through the maze, ultimately again representing that they potentially have this kind of mental map. So when we look at issues related to mental maps, we can absolutely also look at issues related to psychophysics. And the idea of psychophysics is looking at this combination between the psychological and the physical world, and how our perceptions are derived based on the physical properties of the world. So when we look at the physical properties associated with stimuli and we try to understand it from a psychological perspective, we can apply these psychophysical principles to memory, especially when looking at issues related to spatial memory. And this is ideal for us because we can actually measure spatial memory objectively, because again, we can actually measure real space in terms of a measurement, and we can also compare our memory to something that's already specifically present for us out there in the physical world for us to be able to indicate if there is accurate representation or not. And one of the things we find related to spatial memory is that even though spatial memory is fairly accurate, again, in comparison to all the other types of memory that we've been talking about, that it always seems that it is fairly accurate. But again, there may be also some deviations from accuracy, and we may want to talk a little bit about why some of those deviations may occur. The first issue that may occur is actually related to the issue of distance estimation. And the reason that distance estimation is so important for us is that we initially always try to estimate the distance between two points. And one of the things that we find is that when people try to estimate the distance between 2 points, their prior knowledge really does play a major factor in terms of being able to guide them and indicate for them what it is that they expect to have those 2 points in terms of a difference. So, the distance between point A and point B should be about this much distance between them based on my previous experience. So when we look at this aspect of distance estimation, we again find that people are generally quite accurate, but then again, there are some deviations in terms of accuracy in where people fail to actually estimate the distance correctly by overestimating or also underestimating the correct distance between them. But we definitely do find that memory associated with the distance itself again falls into this pattern of having issues related to overestimation and underestimation. But if we look at the distance between 2 points, we actually are fairly accurate in terms of perceiving what the amount of distance between those 2 points may be. So the idea here is that potentially the inference that we're making is going to be the worst kind of representation that we're going to be having, because here, even though you may not have the accurate amount of information based on the previous experience, your inference alone of what the distance between those 2 points might be might potentially be very, very far off from whatever it is that we actually find in terms of the true distance between those 2 points. So this again relates back to the issue of our mental maps, and looking at how mental maps ultimately can be created, we can look at 3 different theories related to mental representation. These are the aspects of spatial theory, temporal theory, and also hybrid theories. So when first looking at spatial theories, what do spatial theories cover? What do they ultimately discuss? Spatial theories essentially say the following: that our mental maps are ultimately spatially organized, and this organization is hierarchical in its nature and not necessarily metric. So in other words, it follows a specific order that we're supposed to have in terms of the hierarchy of where things may potentially be, but not necessarily in terms of a specific measurement distance. And here we also find that memories tend to be distorted based on the region that we're looking at. And again, this aspect of distance estimation for memories are generally influenced by how many things are going to be presented within our distance, within our way from point A to point B. So in other words, if there are other issues that may be present that are potentially blocking or intervening between point A to point B, that may ultimately change the way that we may have a memory recollection of what the correct distance may be. So again, think of them as interfering factors in that potential instance. And one of the things that we find that's very interesting associated with spatial theories is that we actually find that map borders play a major role. We actually find this related to now whenever it is that there are no more borders presented during a person's experience or a person's city. So take for instance when there was the wall that separated East and West Germany, 15 years after reunification, individuals who were German citizens still overestimated the distance between East and West Germany. And a lot of that is actually based on their previous knowledge. So here, what it is that they assume should potentially be that distance, because again, that border really does mark out for them where the specific differences should be between one area to the next. And they also found in terms of this group of researchers, they found that this was much more pronounced, that people had a very negative opinion of the reunification. So they felt that there should be a larger distance between them, even though there really was not that big of a distance between those two areas. Now, we also find that priming is a very important mechanism that ultimately can tell you the spatial distance between multiple objects. And a lot of it is in reference to the aspect of having a reference point. So the reference point or this landmark may potentially function as being a prime that may indicate for you where specifically that other point may be. So in other words, rather than going from point A to point B, you go from point A to point A1, which is going to be a landmark, and then you know the distance between those 2 points, and then you can use that landmark and you know the distance between point A1 to point B. So rather than trying to estimate point A to point B, which you may potentially be off because you may have never had that direct experience, you may actually be able to use a landmark to being able to estimate correctly in those instances. But, of course, that's not always the case. We also do find that landmarks sometimes tend to create under and overestimations of the specific distance between points, because, again, you may use them as a reference, and you may say, well, if I know the distance between here and there, and I can inference then between that point and the other point, I may potentially be off in that instance. Now, our second type of theory that we're going to look at here is the issues related to temporal theory. According to temporal theory here, our mental maps are actually organized by order of acquisition. So in other words, the time that we actually acquired them in terms of the order and also the spatial proximity are used that they're usually confounded during learning. So in other words, the issues related of time and organization seem to be off because we have to make sure that we keep the order aspect intact. So in other words, when I'm driving from here to the mall, what is going to be in my way? So street A, street B, street C, and so on and so forth until I reach my destination. So here you have to have that temporal order, and that temporal order is going to be very, very important aside from just the actual spatial proximity. Now, last, we look at issues related to hybrid theory. Now, according to hybrid theory, our mental maps use both spatial and temporal organizations. So in other words, rather than just looking at the spatial or the temporal issues, this hybrid theory takes into account that we should be able to use both types of organization to be able to create the correct mental map for ourselves. And again, this is now somewhere where we're much more inclined to being able to say that we have evidence for, that we are much more inclined in saying both order and distances amongst the specific points are going to be very important to being able to create that mental representation for the person. And now we can also look at dual process theory as being a component associated with trying to understand issues related with mental representations or mental maps. And according to dual process theory, we can actually have coarse-grained processes for categorical information, such as regional information, versus very fine-grained processes for detailed information. So again, very much here like hybrid theory that takes into combination the temporal and the spatial components, dual process theory looks at the more global aspects in terms of those coarse-grained processes, so the larger pieces of the information or the larger pieces of the map versus the fine-grained processes. So here the much more detailed specific issues related to your mental map in those particular instances. Now, we find that performance is really a mixture of these two, that it's not just looking at the coarse grain processes or the fine grain processes, but rather the combination of the two that ultimately lead us to being able to have the correct estimations, or at least moderately accurate estimations in those particular cases. Now, the last thing we'll talk about here in terms of mental rotation is the issues related to the last thing we'll talk about in terms of mental maps will be mental rotations. And in terms of mental rotations, part of what we have the cognitive ability to do is rotate objects in any way that we can. And this is very important for us whenever it is that we have to understand that there may be different angles that we may be able to view a specific object, or even think of a map in a different way. So when you're driving down a street in your mind, right? So you're driving down one of your main streets or one of your main highways, and you're thinking of it in your mind. Here you can picture that road from a various different angles. That's the aspect of mental rotation, that we're able to use those different viewpoints to being able to create an entire mental map, not just having one specific viewpoint that may indicate for you what it is that you're supposed to be viewing in those specific instances. Now, one of the things that we do also have to take into consideration is that depending on the angle or the viewpoint that we're taking in terms of that specific stimulus or that specific road that we may be interested in looking at mentally, that may potentially lead us to having more errors if it doesn't necessarily match up to our original representation. So here it definitely takes more effort for us and have a little bit more of the aspects of experience to really be able to have a good mental rotation process. And this is actually a very important skill that people can develop. And there are variations in terms of just normal individual differences between individuals in terms of this ability. And we find that some individuals are better at mental rotation than others, and don't have so many problems associated with angle estimations versus other individuals in those particular cases. Now, let's shift our attention here to talking a little bit about temporal memory, so the aspects related to time. So we've talked about the issues related to maps, but now let's talk a little bit about what it means in terms of time. So the issues related to time really refer back more to the issues of long-term memory. So here we have to go back introspectively and look at the issues related to things that have already occurred to us in the past. And this is actually a very difficult thing to do, in terms of trying to estimate when things happened, and not just how things happened, but the aspect of when the thing happened as well. So here, this is a very, very difficult task, because generally, again, we tend to overestimate and we tend to underestimate in some particular instances when specific activities may have happened. So one thing that we may have to consider here in terms of temporal memory is the issues related to temporal distance. So how long ago did that actual memory or that event take place? The longer it's been since things took place, when it was that you created that memory, it's going to be less accurate, because there's so much more things that could potentially interfere and create proactive or retroactive interference for you in terms of trying to have the right memory being expressed at a later point in time. And now we also have to look at the issues related to temporal location. So when in the past did this actually occur? This is something that we're much more accurate in terms of being, so it was when I was younger, it was, 10 years ago or around 10 years ago, so on and so forth. You can estimate that aspect in terms of time, in terms of locating that memory, in terms of that time factor, but in terms of actually having the information being able to recall it, in terms of the specific details, that may be quite a little bit more difficult for you. Now, we also have to look at the issue of relative time and relative ordering. And part of what we have to understand related to ordering is that with time, we definitely do see that it's going to be a lot more difficult for you to be able to estimate correctly what the specific order of events may have been. So what was the actual sequence of events that took place? And you may jump around, especially if that memory has been a very, very long time ago. Now, we also look at the age of the memory. So again, we find that the older memories are much more harder to locate in time than more recent memories. This goes in conjunction with the ideas of serial position effects. So we've talked a little bit about serial position effects, the primacy and the recency effect earlier on in the semester. So the idea of the primacy effect is that things that occurred at the beginning of the list, we tend to recall those much more than the things that occur in the middle of the list, and things at the end of the list we're much better at also being able to recall. So the issue of memory age is that things that occurred such a long time ago, maybe at the very beginning of the list here in terms of time now, that stuff seems to be recalled less and less accurately, because it's been such a long time ago and you may have not actually had time over so many years of thinking of some of those potential memories. And now that somebody brings it up, you try to recall that information, and you do recall some of the information, but it has a lot of gaps. It has a lot of holes. So here, what are we trying to do? We're trying to say, if you're trying to remember things from your past, and so something that occurred 20, 30 years ago, here, over those 20, 30 years, maybe think about it from time to time and always be thinking back to that original memory, so that way you have a good representation later on when you may potentially need that. Now, we also definitely see that there are issues with what we call scale effects. And this is actually, we find that it's accurate at one level of scale, but actually wrong at another. So in other words, people may get the day right, but may get the month wrong. So in other words, I remember it being like on the 20th, but the 20th of October, when in reality it may have been the 20th, but the 20th of July. So here on the smaller scale, they're much more accurate in terms of something such as the day, but in terms of the month, they're much more inaccurate in those particular cases. Now, we also find that telescoping effects are very important and may potentially affect the aspects associated with temporal memory. So with telescoping effects, there's actually two types, what we call forward and backward telescoping. With forward telescoping, this is where we have older memories that seem to be much more recent in their nature, versus backward telescoping, where we have very recent memories seeming to be a lot older. So something that may have happened to us a year ago, we say, man, that was such a long time ago, and you make it seem like it was 10, 15 years ago, when in reality it was just last year. Versus forward telescoping, where we say, man, that just happened. I'm guilty of doing this all the time, that I say, oh, this happened recently, and then I'm talking about things that happened months ago. That's the aspect of forward telescoping in that particular case. Now, again, we also definitely see that serial order effects also may potentially affect the issues related to temporal memory. So the order of recollection is generally preferred, especially when you're thinking about the sequence of an event. So what happened at the wedding, and you go through all the sequence of events, but that also seems to be a very hard thing to be able to recall correctly, especially if it's been a very, very long time ago. Now, the last thing here that we're going to talk about is the issues related to distance-based processes. And one of the things that we find here is that estimation may reflect a memory trace's strength. So in other words, here, if we're looking at the relationship between memory A and memory B, so the term apple and the term orange, but you never really associate them for a very long time. You've associated them in the past when you were a child, but now over the years, you never really think of them together, or whatever the case may be. Here, that can ultimately evaluate for us this aspect of distance between those memory traces. So here's something that's primed up a lot faster. If we say apple, you say orange very quickly, that would give us here this indication that they may be more strongly associated with each other, and they occur much more closely in terms of time. So in other words, they seem to occur much more closer in sequence, much more frequently. So again, we find that also with memory traces for older memories and younger memories as well, that with older memories, the older the memory trace is, the weaker it tends to be, because again, you think about it less. You don't make the association that much, even though you have made the association in the past and there is an association. You don't make it as frequently. Thus, we have a lot harder time being able to accurately recall that information, again giving us this idea of distance-based process. And again, the stronger the trace that we actually have, so the faster you're able to recall that information, and the more accurate you are able to be able to recall that information in a timely fashion, giving us more of the indication that it probably occurred much more frequently for you, in contrast to it having occurred at a longer period of time. All right, so that wraps up our discussion associated with temporal memory and also space memory. If you have any questions for this week, please make sure to email me or call, and I'm happy to answer any of those questions. I do definitely recommend that you all look on Blackboard to see what is due for this week's content. And if you have any questions or concerns, please do let me know.